Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 14th video lecture on the course Logic Programming for Artificial Intelligence. In this video section, I will discuss about uninformed search and informed search. So these are the topics I'm going to discuss. First, we'll discuss about the uninformed search, which is also called as the blind or the exhaustive search. Then we'll go for informed search, which is also called as the heuristic or the intelligent search. Then to understand the heuristic search technique, we need to understand what is heuristic function, then what are the types of heuristic functions and the categories of heuristic search strategies or the techniques. So before going to discuss, let me tell you the topic learning outcome, as I'm going to discuss about the uninformed search and informed search in artificial intelligence. So based upon the uninformed search, after the completion of that topic, students can understand the concept of uninformed search, where the little or no domain-specific information is available to guide the search process. And second one is related to informed search. So after the completion of the topic informed search, students can understand the concept of informed or heuristic search, where the additional informations are used to find the best possible solution without exhaustively searching every possible state. Now, let me discuss what are the types of search strategies. In my previous video already, I introduced what is the meaning of search techniques or search strategies. Basically, the search strategy, actually we know that artificial intelligence is used to solve simple to complex problem. So to solve problem in AI or using AI, the techniques are used. One of the technique is search strategies. So search strategies is a technique which consists of the search space, search tree, and start state, goal state, and some transitional state to solve the problem. So basically, there are two types of search strategies. One is uninformed search, another one is informed search. So uninformed search, it is also called as the blind search. It is also called as exhaustive search, or it is also called as brute force search. Informed search is called as heuristic or intelligent search. Now we will understand why these techniques are called as in different names. Now, let me discuss about this uninformed search. Actually, the uninformed search, as the name it implies, uninformed, so it does not contain any domain-specific knowledge. So, domain-specific knowledge means where the search is present and how to search the tree. It knows how to search the tree and how to find out the leaf node, how to find out the goal node. That is why it is called as it operates in a brute force way, but it does not contain any domain specific information or domain knowledge in advance like other search techniques. That means the search techniques and the location of the search space, it is not known to the AI agent in advance. That is why it is called as it does not contain any domain specific knowledge, but it operates in a brute force way, means it knows how to traverse the search tree and how to find out the leaf node, how to find out the goal node. That is why it is called as the brute force way. It is also called as blind search because blind it tries to follow each and every node of the tree to find out the goal node. So that is why it is called as blind node. The number of possible ways are available in the search space. All the spaces will be traversed by the search agent. That is why it is called as blind search. And it examines all the node of the tree until it achieves the goal node. That means if suppose the tree consists of 10 nodes, all the nodes will be traversed to find out the goal node. That is why it is called as blind search, or it is also called as it examines each and every node of the tree. So that is why it takes lots of time, so it may not be very much efficient compared to other search techniques. So these are the techniques which comes under uninformed search, like breadth first search, depth first search, depth limited search, iterative depending depth first search, uniform cost search, and bidirectional search. All these search techniques I will discuss in my upcoming videos, which comes under uninformed search. Now, what is informed search, or else it is also called as intelligent search? As the name it implies, informed, so that is why this search technique uses the domain knowledge. That means in advance knowledge about the search space would be there for the artificial intelligent agent. That is why it is called as intelligent search, or it is informed search. It can find a solution more efficiently compared to uninformed search, and it guaranteed to find a good solution, as the informed search contains in advance information to traverse the tree or to search the space. That is why definitely it will give it is guaranteed to find the good solution. It may not provide the best solution, but at least it gives guarantee to find out the good solution, and it solves mostly complex problems. And one of the important characteristic of this informed search is the heuristic function. Because of this, we are saying that it is an informed search. So heuristic function, normally it is denoted as H of N. H stands for heuristic. Heuristic means in advance. So N is nothing but the current state. Here I have mentioned N is nothing but the current state, and H of N is nothing but the heuristic function. So what it does, it maps each state to a numerical value to depict the goodness of a node. So that is why this is the representation of the heuristic value. For example, if I say this is my tree, this is my search tree, okay, and these are the nodes A, B, C, D, E, F, G. Now, for example, the heuristic value of H of C is equal to 2, H of B is equal to 3. So H of C is equal to 2, and this is my suppose starting node, and this is my F is my goal node. Now, from the start node to the goal node, what would be the distance? Some actual distance would be there. So the actual distance, for example, here from A to G, the distance is 1, and C to F distance is 2. Right? So actual distance, it is from the node A to the node F, it takes 3. But whereas it is given, the heuristic value of C is given as 2. That means if we traverse from A through C, then we can see, that means the straight away distance, heuristic cost means the straight away distance or the straight distance from that node to the goal node. So H of C is equal to 2. That means the distance from the node C to the node F is considered as 2, the straight line distance. Now, what would be the total distance if I want to traverse from start node A to the goal node F? Then the cost would be like H of C. So that is equal to this 1. So this is that is equal to 1 plus 2, that is equal to 3. Total cost would be 3 to reach from starting node A to the node F. Now, let me discuss about the informed search. What are the informed search types, or what are the algorithms comes under informed search? So these are the following algorithms comes under informed search, like hill climbing, best first search, A-star algorithm, AO-star algorithm, beam search, and constant satisfaction problem. Now, let me discuss about this heuristic function, which is the main important concept of informed search. So, as I discussed just now, heuristic function, which is denoted as H of N. So, it gives an estimation on the cost of getting from node N to the goal node. Now, you can, to make you understand, I have taken one example here. Now, you can see two locations are there. One is the starting location is Mumbai and the ending location is Goa. And two routes are there. Route 1 is denoted as R1 and route 2 is denoted as R2. Now you can see from Mumbai there are two routes. Either we can follow route R1 or else we can follow this route R2. This is R1 route, or else we can follow this R2 route. Now, when the agent will be there at Mumbai, what the agent will observe? Which one is the least distance if I go through R1 or R2. Now till R1 some distances are given. Here from Mumbai to R1 distance it is given as 40 kilometer, whereas from Mumbai to R2 distance it is given as 70 kilometers. So what our human psychology says, if the distance is less, definitely will follow that distance only. Now if I follow the distance, least distance, that means 40 kilometer path, that distance, then what would be the total distance here to reach Goa? So one is 40 plus here from R1 to Goa it is given as 300 kilometers. So 40 plus 300, which comes under total 340 kilometers. But if a person will, or if the agent will follow from Mumbai through R2, that means 70 kilometer, then then agent has to follow this 200 kilometers, so it becomes 270 kilometer. So which one is the least distance? Actually the least distance is through the route R2. But when we see, when we observe from the starting node, between this 40 and 70, 40 looks like the least distance. So if we follow, we may take more time to reach the destination. Now to understand this one, here one value is given, the heuristic value. If I follow this 40 kilometer route from Mumbai, then at the location R1 some heuristic value is given. The heuristic value of R1 it is given as 300. That means h of R1 it is given as 300. That means the straight line distance from the route R1 to the destination it is given as 300. And same thing here for R2, h of R2 it is given as 200. So that means the straight distance from R2 to the Goa location it is given as 200. So this is one example how to check and which route the agent has to move based upon the heuristic value. Now I will explain how to whether that heuristic value is admissible or not. Now here the heuristic search, it is an informed search, as it is informing us how far it is from the goal state. That is what I discussed. Now you can see in this example, here the heuristic function, how we can denote. Now there are three locations. One is the location X, another one is the location Y, and third location is Z. So starting location is X and the goal node is Z. Now heuristic value of X, always it is equal to 0, because that is the starting node, so no need to discuss about this one. Now here it is given as the number of steps to reach the goal state, or the heuristic value of X is given as 2. That means what? Here h of X is equal to 2. As I told, X is my starting node and Z is my goal node. So to reach from start node to the goal node, how many steps are required? So this is 1 step and this is 2 steps. So we can write h of X would be 2. Now similarly I can write h of Y. What would be the heuristic value of Y? How many steps are required? From Y to Z it would be 1. Right? And what I can write h of Z, because it is the goal node, so there is no heuristic value for any goal node. It is considered as 0. So here h of X is equal to 2 means 2 steps are required from X to Z. So it is always considered as the straight line distance from the starting node to the goal node. And similarly h of Y, it requires only 1 step to reach the goal node. Now there are two different types of heuristic function. One is admissible, another one is non-admissible. When we can say that the heuristic function is admissible, means it is applicable. And when we can say that the heuristic function is not applicable, that also we need to understand before the use of the heuristic function. So the condition here I have mentioned, h of n is less than is equal to h star n. So where h of n is the heuristic value and h star n is nothing but the estimated cost, which is also called as the actual cost. So when we can say the heuristic function is admissible, if it never overestimates the cost of reaching the goal state. I will show you with the help of one example. So this is the condition we have to remember. H of n is less than is equal to h star n. So that means the value of the heuristic value of any node, it should be less than is equal to the actual cost from starting node to the goal node. That is the condition, then only that heuristic value is applicable. So here heuristic cost should be less than or equal to the estimated cost. Now, when we can say that the heuristic function is not applicable or non-admissible, a non-admissible heuristic, it may overestimate the cost of reaching the goal. So the condition is h of n is greater than h star n, where h of n is the heuristic function or heuristic value of a particular node. If it is more than the actual cost of the total path, then in that case the heuristic value is not admissible, right? Now, one more function we need to remember, one of the formula, total cost. How to find out the total cost starting from the start state to the goal state? This is the formula. Total cost is equal to heuristic cost plus actual cost. So here we can represent f of n is equal to g of n, h of n plus g of n, where h of n is the heuristic value of a particular node and g of n is the actual cost starting from the start node to the current node. Now, if I say, for example, this is my tree, right? I will take a small examples to make you understand. If this is my tree and the node, this is my A node, B and C, this is D, this is E, this is F and this is G, and the heuristic value, for example, it is given as B of is given as 2, and the cost is given as from A to B, A to B is given as 1 and B to D is given as 1, B to E is given as 1. Suppose this is 2, this is 3, this is 4. Now, if A is my starting node and D is my goal node, then how to find out the cost of the node B? Always we have to find out the cost of the child node. So how we can find out the cost of node B? So h of B, total cost of B, h function of B node, that is equal to h of B node plus g of B node. So what is the g? Now h of B is already given as 2. So I can write 2 plus what is the actual cost of B? So g of B is treated as starting from the starting node to the current node. Now my current node is B. I am calculating the total cost of B. How much cost is required if I move through B node? So that is why as we are calculating f of B, that is equal to h of B plus g of B. G of B means starting from the starting node to the current node. Now the value is 1. So it becomes 3. So cost of f of B is equal to 3. This is the way we can calculate. Now we'll see one of the example of admissible function as well as non-admissible function. Though I told the condition h of n should be less than is equal to h star of n. That means the heuristic value, it is always less than or is equal to the total cost. Then only we can say that the heuristic value is admissible. Now you see the search space where we have so many nodes are connected. Like the starting node is A, followed by B, C, D. Then from B again E is there, then F and G. And in this search space, A is the starting node and G is the goal node. And with yellow mark, some values are given. The heuristic value of B is given as 3 and the heuristic value of C is given as 4. Heuristic value of D is given as 5. Similarly, for E it is 2, for F it is 3. And anyways, there is no heuristic value for the node G. Now, if you see, then how to traverse, how to find out the shortest path from A to G. Now, as if from the node A, there are 3 options. So one is B, another one is C, another one is D, right? Now, how to find out, so what is the cost of B? If I find out the cost of B, then f of B, that is equal to h of B plus h of B plus g of B. This is the formula, right? So as the formula is, as I told, cost of any node, that is equal to Fn is equal to h of n plus g of n. So every time we will use this formula to find out the cost of a node. So f of B is equal to h of B plus g of B. So what is h of B? It is given as 3 plus g of B, this distance. G of means starting from the start node to the current node, so which is given as 1, that is equal to 4. I hope you can find out how to find out the cost of node C, that is equal to this 1 plus 4, it becomes 5, and cost of D node, that is equal to 1 plus 5, that is equal to 6. Now, among this 5, 4 and 6, who is having the least cost? So, 4 is having the least cost. That means the agent should traverse through node B. Anyways, in this search space, it is visible that there is no connection between C and G. Even there is no connection between D and G, agent cannot traverse. So, we'll follow the path B. Now, while traversing when we will follow the path B, now we will check whether all the heuristic values are admissible or not. So that is the main motto of this session. Now we'll check here whether this H of is admissible or not, H of F is admissible or not. How we can check? Now if you find out the actual cost starting from the node A to the node G, what is the cost? So this is 1 plus 3, 4 plus 5, 9 plus 2, 11. So actual cost. So what is the actual cost here? Actual cost, that is equal to, means the total cost we can say here H star n, that is equal to 11 from A to G. Now here, what is the heuristic value of B? Heuristic value of B, that means H of n is equal to 3, which is less than is equal to 11. So, this value is admissible. The same way, we can say H of n, like for E node, it is given as 2. That means 2 is less than is equal to 11. This condition is satisfying as H of n should be less than is equal to H star n. This is our condition for admissibility. So 2 is less than 11. Even for this F node, H of F node, that is equal to 3 is given. 3 is also less than is equal to 11. So all these heuristic value through this path is admissible. So this is the way we can check whether the heuristic value is admissible or not. If it is admissible, then only we can find out the cost of the path. Now we'll check whether the cost is not admissible or not. Now in this diagram, if I draw a connectivity line from the node D to the node G, just to show how the heuristic value is not admissible. Now you can say, suppose my start node is A and the goal node is G, and I want to traverse from A to G through D. Now what is the heuristic value of D is given as 5. What is the condition for non-admissible? H of n, if it is more than is equal to H star n, then in that case the heuristic value is not admissible. So H of D is given as 5. What is the total cost from A to G? You can see 1 plus 3, that is equal to 4. This is the total cost. But what is the heuristic value of D? That is equal to 5. Now heuristic value of D, which is nothing but H of n. Now H of n is equal to 5. Okay, here D as heuristic value of D is given as 5. So heuristic H of n is equal to 5. What is H star n? Means the actual cost starting from the start node to the goal node through D. That is equal to 1 plus 3, that is equal to 4. So now 5 is greater than is equal to 4. As this condition is satisfied, so that is why this heuristic value is not admissible. We cannot use that heuristic value while solving the search space. So this is the way we can understand whether that value, just I told how to check whether the heuristic value is applicable or not in our search space. Now there are two different search techniques or heuristic search techniques are there. One is direct heuristic search techniques, another one is weak heuristic search technique. So direct heuristic search techniques is that it includes the blind search, which is also called as uninformed search or blind search strategy. Basically, the uninformed search is called as the direct heuristic search. There is no in advance information for the AI agent to traverse the tree. So these search techniques are not always possible as they require as much memory and time, because as it traverses all the nodes to search the goal state, so it takes lots of time and lots of memory. So that is why it is not the efficient one. So these techniques search the complete search space for the solution and use the arbitrary ordering of operation, because all possible paths it tries to find out the goal state. So example is your BFS and DFS. So as there is no in advance information, that is why it is called as direct heuristic search techniques, or else it is called as uninformed search techniques. Whereas the weak heuristic search techniques, it includes the informed search, which is also called as heuristic search and heuristic control strategies. These techniques are helpful when they are applied properly to the right type of task. So they usually require the domain-specific information. Example is your best first search and A star. As I discussed the difference between informed and uninformed search. So normally the direct heuristic search techniques are nothing but the uninformed search, where there is no in advance information or there is no heuristic function. Whereas in case of the informed search or the heuristic search techniques are called as weak heuristic search, or the like your domain specific information search. So this is all about for this particular video. I hope you might have understood the difference between the heuristic search and the direct heuristic and weak heuristic, as well as I discussed about the heuristic function, how whether that heuristic function is admissible or not admissible. I hope you might have enjoyed. So for the preparation of this video, I referred these two textbooks. One is the S. Russell P. Novick for Artificial Intelligence and Soros Kosick for Artificial Intelligence. So next class I'll catch you. Till then, take care. Bye bye. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.